All right, here we are in chapter 3, and this is section 4 on present value of an annuity and amortization. All right, so the present value of an annuity. What we're looking at is the how much it's going to be in a present value. So how much should you deposit into an account now, paying 7% compounded semi-annually in order to withdraw $2,000 every month for the next 2 years? Now, assume that after the last payment is made, no money is left in the account. And we find the sum of the present value for each $1,000 that is paid out during the 2 years by solving for P in the compound interest formula. So this is just going back to our compound interest formula, and then we're solving for P for each of the four payments. And we find that P is equal to A, and then we have 1 plus I over to the n, and so then that's equal to this. If we take it to the negative, so we bring this up here, so it's just on one line. And then the rate we found is 0.03, so we examine each payment separately now. So what we're going to do is first payment basically is we're taking a 1,000 times the 1 plus the I to the negative n is 1, so it's going to give us $970.87. Now plugging in 2 in here, we're just going to plug in a 2 and we get 942.60. Plug in a 3, we're going to 915.14, and then plug in that 4, we get 888.49. Now, if we summarize all that and put it all in just kind of right beside each other, we can get a total of $3,717.10. And what that is it looks like this. And so with algebra, what we can do is we can come up with a formula that would get it. So we each have of those 1,000. So we pulled that out front. And then what's left over? Well, it's going to be 1 minus this quantity divided by this. And these are I's, that's our N. And so we get the nice formula for an annuity as the present value is equal to the payment times 1 minus the quantity 1 plus I to the negative N all over I. And so these are what that we have. And the key here is I is the rate per period. Okay, and N is the number of periods. Everything else is pretty self-explanatory. All right, let's stop there and we'll come back for some more.